Hi again, everybody. It's good to see you. We're going to complete now 4.3 with the second type of absolute value inequality. The first type, in review, just briefly, said this: if the inequality symbol is linked to, is less than, or is less than or equal to, the translation of that inequality will be to a conjunction, an and, written in compact form. But now we're going to move to the second type. And that is the type where the inequality symbol is linked to is greater than or equal to. And we're going to find out in a moment that whenever you have an absolute value inequality that is linked to is greater than, the translation of that inequality will always become a disjunction, an or, a union of sets. Let's consider this problem. Let's consider the absolute value of x is greater than 6. Now let's translate. X must be a real number whose distance away from 0 on a number line must be greater than 6 units. Let's look at the number line. I've got 3 critical values on it: 0, positive 6, and negative 6. X must be a real number whose distance away from 0 is greater than 6 units. On the positive side, all values that would be greater than positive 6 would cover a distance away from 0 more or greater than 6 units. So the graph of the part of this that speaks to the fact that x can be any real number that is greater than positive 6, we would make a parenthesis, and it would open up greater, and it would represent all of those points. Now, before we leave this little part of the number line, let's just check some values right here just to make sure that what I have graphed so far is okay. Let's pick 7, because 7 is a greater distance away from 0 than 6 is. The absolute value of 7 is 7. 7 is greater than 6. It's good. But if you try a value like 4, you put 4 in there, the absolute value of 4 is 4, and 4 is not greater than 6. So it certainly can't be any of those. It's got to be those in part. And now let's move over to the other side. The critical value of negative 6 is 6 units away from the origin, just so happens to be on the negative side. So all of these values right here to the left of negative 6, all of these values would represent a distance greater than 6 units away from 0 on the number line. Not these. They're a lesser distance than 6. So it would appear that if we put the parenthesis opening up less than negative 6 and shade the rest of that, let's try negative 7. Negative 7 is in this vicinity. If you substitute negative 7 in there, the absolute value of negative 7 is 7, and 7 is greater than 6. None of those will work. Folks, look at the completed graph. That is not intersection. The wings of that graph, the intervals of that graph are pulling away from one another. They're pulling apart from one another. This is an OR. This is a disjunction. Let's write out this solution using interval notation. And it doesn't matter which interval you begin off with. I'll begin with him. X is less than -6. That's this part. Or X is greater than 6. That would satisfy that. When you write your interval notation, you can write it in this way. You can also do this. Put this, if we were to look at this particular one in interval notation, this is more or less the solution. In interval notation, you'd put dual parentheses, put the -6 for the highest, the lowest, -infinity, then the union symbol, and then a parenthesis, and another parenthesis, and 6 would be the smallest, and the positive infinity would be the largest. This would be the interval notation. This is more or less just the overall solution of it. So whenever the absolute value inequality is linked to is greater than, it's always going to be a disjunction. And I won't read that. You can read it right now before we let it go, because that is exactly the truth. So up here in blue, before we kind of erase this board and move into some examples, here is the rule for an absolute value inequality that is linked to is greater than. And here's the statement. If the absolute value of U is greater than C, then U will be less than the opposite of C, which means a positive, or U would be greater than C. That's the translation of it. I want you to notice a little bit of a pattern right here before we erase this. Because just like the prior absolute value inequality had a pattern when we had translated it to compact form, this one as well has a pattern. It's a little bit more detailed. You'll have to do a little bit more memorization of this one, but let me share what it is. If the absolute value of U is greater than C, then I'm going to read it kind of in this way. You bring down that algebraic expression, and it will be greater than the positive value, or bring down that algebraic expression, and here would be the key word. You change this symbol to its opposite. U will be less than, and you then change that positive number to its opposite. So if there were to be a key word for this translation, I believe it would be the word opposites. The U's are the same, but the inequality symbols are opposite, and the C values are opposite. Now we'll show it when we actually get into this and do some examples, and I believe you'll see how nice it will be when we deal with it. So let's go to number 1. The absolute value of 2x minus 5 is greater than or equal to 3. The absolute value expression must be isolated, and it's isolated. Maybe the next thing that you just might want to do, it's arbitrary, it's optional, but you have to look at this road sign. Because people, this road sign is going to tell you whether it is a conjunction or a disjunction. It's linked to greater than. I'm just going to kind of put this off to the side. I believe that's key. This is going to be an or. Now here's the translation. Bring down that 2x minus 5. I'm going to write it maybe right about here. You've got to start somewhere. I'm going to start with the comfortable one. Bring down that algebraic expression and set it greater than or equal to 3. I'm kind of starting with the one on the right. I could have put that on the left. It doesn't matter. Or we bring down that algebraic expression. Now listen to the words. Opposite, opposite, opposite. And there's the translation. So I'm going to tell you what I'm going to be doing before we just go into this and solve it. When I change this absolute value inequality to the or statement, I'm going to write down the positive one first. The 2x minus 5 is greater than or equal to 3. I'm just going to write down exactly what I see here without the bars. Then I'll move to the opposite one. Now, let's solve this one. Positive 5, positive 5. 2x is less than or equal to 2. Over 2, over 2. X is less than or equal to 1. Or, here, positive 5, positive 5. 2x is greater than or equal to 8. Over 2, over 2. Or, x is greater than or equal to 4. Now there was the overall solution that we got. Now we're going to get the graph on there. Make a number line. There's 3 critical values. 0, 1, 4. Those are the critical values. Now let's graph. On the one hand, x must be less than or equal to 1. Less than or equal, we need a bracket going right through positive 1, and it's got to open up in the way that the symbol is pointing. And then we shade. Or x is greater than or equal to 4. Right through 4, a bracket that is projecting greater than 4. Shade it with the arrow. There's the graph. And now let's show the interval notation. We begin with this bracket, and to its left we'll put a parenthesis. The largest value of this interval is 1, and the smallest is negative infinity. Then I'm going to put the union symbol, and then we'll put a bracket and a parenthesis. It will begin with 4, and it will end with positive infinity. There it is. That is a typical looking absolute value inequality that deals with OR. That is a disjunction. Number 2. The absolute value of 3 minus 3x over 4 is greater than 9. Absolute value is isolated. Greater than. Or I'm going to write this statement first, kind of to the right. I could put it to the left, but I'm going to stay consistent. 3 minus 3x over 4 is greater than 9. Or, start again with your algebraic expression, or 3 minus 3x over 4. Change this puppy to its opposite, and change that positive value to its opposite. And there's our translation. Now we want to get rid of the fraction. So we'll tuck both sides, and I'll go ahead and tuck this as well. Going back to this one, we'll multiply both sides by 4. So folks, watch the number of times that I write the 4 down. I'll put it right there for that positive 3. I'm going to stick another one right there, and that 4 will be reserved for this fraction. And then I'll just kind of insert another 4 right there. 1, 2, 3 terms. 1, 2, 3 4s. 12. Negative. The 4s will cancel out. We'll be left with 1 times a negative 3x. A negative 3x is less than 4 times negative 9, negative 36. Now you got to stay on top of your toes when we're doing this. Next step, get rid of that 12. And now we're down to a negative 3x is less than a negative 48. Now we're going to have to divide both sides by a negative, so that means we're going to have to reverse. So negative 3x divided by negative 3 will be greater than negative 48 divided by negative 3, and x will be greater than 16. And we'll get that word or written down. So there's a little bit to think about just on this one right here that we had to do. We had to get rid of the fraction, and then we had to deal with this negative 3x term to where we had to reverse that inequality symbol. Here, we're going to multiply both sides by 4 as well. Once, twice, third time. 12 minus the 4's cancel. We're left with, again, a negative 3x is greater than 36. Negative 12. Negative 12. Negative 3x is greater than 24. Going to have to reverse. Negative 3x divided by negative 3. Reverse him. Is less than 24 divided by negative 3. Or x is less than negative 8. There's, so to speak, the solution. Now I'll kind of put it up here. Let's go to the graph. Stick a 0. Maybe put right about there your negative 8. And down over here, 16. On the one hand, x has to be greater than 16. A parenthesis, going greater than 16. Shade to the right. Or x is less than negative 8. A parenthesis that's going to project less than negative 8. To the left. And shade. They're set apart. Now the interval notation. Parenthesis, parenthesis, union, parenthesis, parenthesis. Negative infinity, comma, negative 8. Positive 16, positive infinity, done. Three multiplied by the absolute value of 2x minus 1 plus 2 is greater than 8. There's no translation yet. Yes, you can look at him. It's like it's going to be an or. But we've got to get rid of that positive 2, and then we're going to have to get rid of this little factor that it will be once he goes. Negative 2. Negative 2. 3 multiplied by the absolute value of 2x minus 1 is greater than 6. Let's get rid of that factor of 3. Over 3. Over 3. The absolute value of 2x minus 1 is greater than 2. Now we have it down to our form. It's greater than, he's positive, he needs to be for us to be able to do the translation. Here we go. 2x minus 1 is greater than 2. Or 2x minus 1 opposite, opposite. Positive 1, positive 1. 2x is less than negative 1. Over 2, over 2. X is less than a negative 1/2. Or, here, positive 1, positive 1. 2x is greater than 3. Over 2, over 2. Or x is greater than 3 over 2. The graph. We'll stick a 0. We've got a negative 1/2. You just kind of put it over here. And 3 over 2. Maybe out a little bit further. And then we'll do the graph. On the one hand, x has to be less than a negative 1/2. It's got to be less than that. Parenthesis. To the left. Shade it. Or x is greater than 3 over 2. Greater than. Shade. Interval. All parentheses. Negative infinity, comma, negative 1/2. Positive 3 over 2, positive infinity, done. So what was the reason for number 3? Had to get rid of him, had to get rid of him. Wanted to make sure that I showed that. 2 more. Let's get number 4 out of the way, because number 5 will be fast. Number 4. Negative 2 times the absolute value of 5 minus x is less than negative 6. We can't change any statement. We're going to have to get rid of this negative 2 first. You'll notice, you might have thought, well, Johnson, you made a mistake because that's not greater than. No, it isn't right now, but it's going to change. Because the first step that we're going to have to do is we're going to have to isolate that absolute value expression, and we're going to have to get rid of that negative 2. And the way that we get rid of that negative 2, because it is a factor. There's a time sign right there. We get rid of that by dividing this side by a negative 2. And because it's an inequality, when we divide by a negative, he's going to have to reverse. So I'm not going to put the fraction bar there, I'm going to bring it down fresh. Negative 2 times the absolute value of 5 minus x divided by negative 2, now reverse, is greater than negative 6 divided by negative 2. They will cancel out. We'll be left with the absolute value of 5 minus x is greater than 3. Now we have our disjunction. Now we have our or. Now we'll translate. 5 minus x is greater than 3, or 5 minus x will be less than negative 3. Opposite, opposite. Get rid of that 5. Negative 5. Negative 5. Negative 1x is less than negative 8. But now we're going to have to divide by a negative 1, and that's going to mean we're going to have to reverse. So negative 1x divided by negative 1 is greater than negative 8 divided by negative 1, and x will be greater than 8. Or, here, negative 5, negative 5. Negative 1x is greater than negative 2. Reverse it. Negative 1x divided by negative 1 is less than negative 2 divided by negative 1, or x is less than negative 2. So a little bit more reversing. We had to reverse from the get-go. And then for each of these separate inequalities, we had to reverse again. So the graph. We'll stick a 0, the negative 2, the 8. X is greater than 8. Got to be greater. Make that parenthesis point greater than. Shade, or x is less than negative 2. Got to be less than negative 2, a parenthesis, shade, parenthesis, union, parenthesis. Smallest, negative infinity. Largest, negative 2. Smallest, 8. Largest, positive infinity. It's a very basic translation to do. You just have to memorize the concept of opposite, opposite. Opposite, opposite. It just has its own little rule. If you use something else to promote the translation, good. Final one. It's a quick one because it won't require really anything. But we have to watch for what we're doing. You see, folks, I'm going to mention this before we do this one. On both of the absolute value inequalities that we did, for us to be able to do a translation either into a conjunction or a disjunction, the value of C, there's your U, the value of C must be positive. It has to be positive for us to be able to translate to a conjunction or a disjunction. If it's negative, then you're going to have a very unusual answer. Number one, it will be easy from the standpoint you will not translate. Like this one. This is saying that the absolute value of x plus 4 must be greater than negative 12. It has to be greater than negative 12 because the absolute value of any expression must be either 0 or positive. It cannot be negative. It can't be negative. It has to be greater than any negative. Well, if we've got the absolute value of x plus 4 that is greater than negative 12, it's got to be true for all real numbers. Any real number will satisfy this. It doesn't matter what the number is, it will pass that test. So there isn't any translation. The graph for this would be a number line. I'll stick 0 on it. The graph would be every single real number. And the graph for all real numbers is the entire number line shaded. That's all real numbers. You can substitute any number in there, and its absolute value is going to be positive. And every positive number is greater than negative 12. The interval notation, negative infinity, comma, positive infinity. And there would be the solution to that. So now that takes care of 4.3. There'll be one last section that we'll have to do in 4.4, and then we'll have chapter 4 done. You have a good day, and we'll talk later. Bye-bye.